Hey, today we will be talking about differential amplifier. Okay, try to review last meeting. In the last meeting, we already talking about the bipolar amplifier. Okay, basically something you must know. You get the common admitter amplifier, common collector, and a common base. Okay, so when you're looking into the circuitry, you have to recognize, is it a common admitter, common collector, or common base? That's the first thing. The second thing, the relation between the input and the output. For common admitter, input applied to the base, and output will be coming from collector. And the input and the output will be opposite or 180 degrees our phase. Okay. And also you have to know the capacitor. Connect to the input, connect to the output. What is the name? Okay. And the purpose for those capacitor. And the capacitor will be at the admitter. The virtue between the input and the output capacitor that DC blocking or LC coupling. That means they block any DC going to the amplifier or any DC coming out of the amplifier. And the resist capacitor at the admitter, that will be bypass capacitor. Okay. Without the bypass capacitor, the gain will be not big. Okay. If you want the more gain for the amplifier, that's why they need the bypass capacitor. And then common collector. You understand the common admitter, that means admitter will be at the route AC route. Common collector will be at the AC route. And common base, the base will be in AC route. Okay? On the formula, basically we don't have to memorize, but you have to general understanding. And today we're talking about differential amplifier.
I got a quick question.
Yes, sir.
My question is for the bypass capacitor, for the help the gain out, is it small or big?
Bigger.
Bigger. Okay, bigger. Thank you.
Okay, now this is a differential amplifier. This is a symbol here. Okay, they get input 1, input 2, output 1, output 2. And this is the circuitry inside the symbol. Okay, they get 2 input here, input 1, input 2. Okay, output 1, output 2. Okay,
Yes, you see.
yeah. The one they call a differential. That means they get 2 inputs. Okay, a differential amplifier bipolar junction transistor amplify that produce outputs that are functions of the difference between 2 input voltage. So now if I apply input sideways, input 1,
Sideways.
sideways, that input 1, input 2 rounded. That means we apply only one input. First thing, you're telling me what the name of the amplified Q1. What Q1? Common collector, common bay, or common collector? Admitter.
Common emitter.
Common admitter. Okay, the thing is input apply to the base. Okay, and output from collector. They will be common admitter. Okay, now if they common admitter, the output they will be look like sideways, opposite, right? 180 degree of phase.
Is this the way you run electricity?
Let me say again.
Is the way that it runs electricity?
It's the way of the Q1. Right now we're talking about Q1. You say that a common admitter, correct? And
Yes.
I said output 1, they will be sideways. However, they will be 180 degree of phase. That means the opposite. And also you get a sideways, and now in at the admitter Q1. Also you get a sideways. We don't have a bypass capacitor, so you still get the sine wave. The next question, what the amplify of Q2?
Common base.
Common base. You get a sine wave applied to the admitter. And the output also the sine wave. However, they will be in phase. You see that? That is really we want you to know. In order to build a differential amplifier, Q1, Q2 will be identical. RC1, RC2 will be the same. Okay? And you can get the current IE1. And the current IE2. Okay, and the current here. Okay. That's a very simple. Here, they give you get more detail here. Assume both transistors are identically. That means they will be the same. RC1 equal RC2. IE1 equal IE2. And that will be equal the IRE divided by 2. Okay? VC1 equal VC2. And that will be equal VCC minus IC1 times RC1. Okay? That's how do we calculate the VC1. VE equal VB minus 0.7. The thing is you get a diode. Okay, so basically they give it to you all of the information for the circuit. Okay, in this case, they route input 1 and input 2. Both input routed. They measure VC1 with a meter and the VC2 with the meter. They just telling you they get the same voltage VC1 and VC2. Now, that's what we already talked to you. Now they apply for Q1 input VB1, VB2 rounded. See what's going on. For this configuration, sine wave connect to VB1 here. Q1 is CE amplifier. Input and output Q1 is inverted. Okay, 180 degrees out of phase. For this configuration of Q2, VB2 is routed. Q2 is CB amplifier. Input and output Q2 is in phase. That's what they want to telling you. Okay. Okay, let's see. Now they will be applied to Q2 and Q1 will be routed. For this configuration, sideway connect to VB2 here. Q2 now will be common admitter. Okay. Input output Q2 is inverted. Okay. And for Q1, VB1 is route. Okay. Q1 now will be common base amplifier. Input output of Q1 will be in phase. Okay. Now, that one, they routed Q2. They apply sideways. Then the output of Q1 sideways but will be opposite or 180 degrees out of phase. And Q2 will be a common base and the output will be in phase with the input. That only thing. Make sure you know. The thing is you get a sideways here. Okay, admitter here. Also they will be get the sideways. So that's why when we asking for what the configuration for Q1, then you have to know that common admitter. And the input output will be opposite. And the Q2 will be common base. And the output will be in phase with the input. Same thing. Now they apply Q2, routed Q1. And you can see Q2 now common admitter. Output will be opposite with the input. And now Q1 will be common base. Input, output will be in phase. Mode of signal operation. Single-ended input. That means they apply input V in 1, V2, input routed. Okay, this is the symbol for differential amplifier. And you get two output, one will be opposite, one will be in phase. Okay, either one, they will be same thing. Apply input 1, then output 1 will be out of phase. Output 2 will be in phase. If they apply at input 2, then 2 will be out of phase. 1 will be in phase. Now, differential input. That means they apply signal into input 1 and also apply the signal to input 2. One thing you have to pay attention. Both input have to be opposite. V in 1 and V in 2 have to be our phase. Cannot be the same phase. Okay? Then you can get input, output 1, and that will be output 2. They will be opposite. Okay? But the important here, when you apply the signal into both input of the differential amplifier, those input must be opposite, cannot be in phase. Common mode input. Both inputs are the same phase, same frequency, same amplitude are applied to the two inputs. The outputs are superimposed and they are cancelled, resulting in a zero output. That means if you apply in 1 into identical signal, okay, the output they cancel out, so you get zero out. Okay. This action equals common mode rejection. That means if they looking in the back, they see the identical two signal here, they cancel out. That's what they call common mode rejection. Common mode rejection means that is unwanted, that means the noise signal will not appear on the output, the desired signal. This it look like the noise. Okay, they affect into input 1 and input 2. That's why they're identical. And the purpose of the differential amplifier try to reject this signal. Okay, I given you the example. If you apply your voice into the differential amplifier, your voice will be around 10 microvolt IMF. That means very, very small. However, you can get a radiation from the power, create a sine wave, very big voltage, 1 volt, peak to peak. That means your voice will be buried inside here. Okay? So the purpose of the differential amplifier try to reject the noise, and they can able to amplify your voice only. Okay?
Yeah, the signal they're running at the same rhythm.
Yeah, very with the same. Okay? The thing is the noise basically coming out from outlet, radiation signal. They
It's
will
going
be
to-
out. They go
It's going,
to
it's going to the right. From the ground to the two is running to the right, the signal.
you mean the go to the right of signal here?
Yes, yes.
That is just the noise. The thing is this one and this one identical. The thing is the noise radiation signal, they will be go to both, not only one. So that's why you can see they draw it. This is a sine wave. This is the sine wave identical. Whatever identical consider to be the noise. Okay? And that's why you can see they prove in here. You can get this one and the other one opposite. So that's why they cancel out. Okay? They say common mode rejection means that the unwanted, that means the noise signal, will not appear on the output, the desired signal. Common mode signal, that means the noise, generally are the result of pick up of radiated energy on the input lines from adjacent line. Okay? What about signal? When you're looking the signal on the oscilloscope, you see cannot see the signal. Okay? That means they be affected by the noise. Common mode rejection ratio, CMRR. The measure of an amplifier's ability to reject common mode signal is parameter called the common mode rejection ratio, CMRR. CMRR equal AV. A means the gain. D means the differential gain. ACM, that means the gain of the common mode, where AVD is differential voltage gain and ACM is common mode gain. The higher the CMRR, the better. Okay? Common mode rejection ratio is often expressed in decibel dB. Next week, I will be talking about decibel. Common mode rejection ratio in dB equal 20 times log of differential amplifier divided to common mode amplifier. If they want to calculate the common mode rejection ratio, they take the differential amplifier voltage divide to common mode rejection amplifier voltage. Now, example, a differential amplifier has a differential voltage gain AVD of 2000 and a common mode gain ACM of 0.2. They want to know the CMRR expressed in decibel. Solution. Common mode rejection ratio equal gain differential divide gain of common mode. 2000 divide 0.2, you get 10,000. Okay, now for now, I can help you. CMRR in dB equal 20
Times
log of 10,000 divide 0.2. Let's see. 10,000. แล้วกับ 10,000. Sorry. And that given you every debate. Okay. In order for you guys understand or not, you doing on number B for me. A differential amplifier at a differential voltage gain 8500 and a common mode gain 0.25. They want to know CMRR also in decibel. So the B, CM, okay, and CM. In debate. Can you calculate that and let me know? So
34,000.
3,500, right? Divide.
$34,000.
Okay, let's see. Is it 34?
I got 37.
The first one CMR, what you get?
34,000.
34,000, correct? And that one will be 20 times 34,000.
$68.
Okay. 34.
90.6 dB.
Okay, times 20.
90.6.
90.6.
Yeah, 90.6.
decibel. That's just a minimum calculation. Try to know how you able to calculate the common mode rejection ratio also in decibel.
Yes, it's 68.
Now, you can say, example, for the differential amplifier circuit, so single-ended output, what that mean? Single-ended output. Normally, you see they draw two output. However, in this case, they're using only one. That's what they call a single-ended output. You get two input, 1 and 2. However, output only one. Okay? And if you're looking into here, This is signal your one. This is your signal. And this is the identical signal. VCM. VCM. That's just a noise. Okay? The effect on the both input. Basically, your signal here will be very, very small. So that's why you cannot see your signal. The thing is this is a noise too big. See what they given. VD, AVD. Differential gain 2500. Common mode rejection ratio 30,000. V in 1, 500 microvolt. I am at that 500 microvolt. I am at. At the same time, a 1 volt 60 hertz common mode interference signal appear on both input. So they're telling you, you get this signal will be 1 volt, 60 hertz. They go both input 1 and 2. So you see your signal only 500 microvolt. See that? Only 500 microvolt. And now you get a 1 volt in here, then your signal really burying inside that one. You cannot see your signal. Okay? First thing, they want to determine the common mode gain, ACM. Solution. Common mode rejection ratio equal AVD divide ACM. AVD you already get 2500. And the common mode rejection ratio 30,000. Okay, that will be helping you to calculate the CMRR. You take 2500 divide 30,000. Okay, you get 0.083. And this is a common mode rejection ratio in decibel. You get 89.5 decibel. V in differential equal V1 minus V2. V1 in here, 500 microvolt. How about V in 2?
One volt.
You don't see any input here, right? That means 0. So they take 500 microvolt minus 0. You get 500 microvolt. Okay? V out equal AVD time V in differential AVD. Okay? 2500. That's the AVD right here. Time 500 volt microvolt. I am at, so that's why you get 1.25 volt I am at. Okay? So basically the differential amplifier, they look back into the input if they see two signal identical. Supposed to be the noise. So that's why they block it. Okay, they not let it go. They allow only your voice able to go to the output. Another example for the different amplifier. Circuit show, same thing, single-ended output given here, okay? Look like, let's see, AVD 2500 common mode rejection, okay? So we already did it. This is just a solution. So basically that's a differential amplifier, very short, okay? When you learning from this chapter, okay, so the emphasis will be common mode rejection ratio. That means they will be block any signal considered to be the noise at the input. Okay, they not allow that go to the output. Okay. Now, next one. Will be the operational amplifier. Op-amp. This is the IC for the op-amp. You get 1, 2, 3, 4, 5, 6, 7, 8. Only 8 pins. And this is a symbol here. Okay. Try to see what the basic definition here. 3-terminal device. You get input negative. Input go to positive. Okay. So this is the op-amp operational amplifier. They get 2 input, 1 negative, 1 positive. Okay. With the input negative, they call a inverting input. And the one in the positive, they call a non-inverting input. Okay. Basically, when you're looking into the input of the op-amp, they will be get the very, very big resistance. Okay. G in. What that means? Input in impedance equal infinity. Okay. That's only telling you. Input they get a very big resistance, so the current cannot go into the op-amp. The thing is, the impedance is too big. Okay. And also, this is the output, V out. AV, that means the differential gain time V in. And they will be coming out. Okay. And also at the output here, also you get a resistance. That's what they call a G out. G out means output impedance. They want it to be a 0. Why? You want the more current coming out, then the impedance at the output supposed to be 0. If this one is too big, that means current cannot coming out. So when you're looking into the symbol, You know this is a differential amplifier. Differential, the thing is to get two input, one at negative, one at the positive. Okay, and the input impedance very big. So current cannot go through the op amp. Okay, and the op amp they will be get the gain. They take the gain times the input. They give you the output. And at the output here, you can get also resistance. That's what they call an output impedance. But they want that to be a 0. So you can get a more current out. And the negative input op amp, they call an inverting input. And the one positive, they call a non-inverting input. Okay? And the differential input VD, they will be the difference between V at the positive minus V at the negative equal 0. That's what they want. V different, VD. VD will be V at positive minus V at the negative equal 0. That will be telling you what? They will be telling you all the time V in positive will be equal V in negative. That's a very important thing. Okay? You have to memorize. When you're looking into the op amp operational amplifier, they get two inputs, one at the negative, one at the positive. Okay? And the name for input negative, they call inverting input. And the one at the positive, they call non-inverting input. And when we're talking about VD, okay, VD, that means the difference between input at positive and input at negative. Okay, they want it to be 0 all the time. That's only telling you the voltage at the positive and the voltage at the negative will be equal. Okay, and here they say VD equal V at positive minus V at negative. Also, they equal 0. Okay, that's what you must be memorize. It's a very, very basic. Okay, so whenever you see that symbol, you know that's a differential amplifier. Okay, and the input in the negative, they call it inverting input. And at the positive, we call a non-inverting input. And they get a very, very high input impedance. So that's why current is not go into the op amp. Okay. And the VD, that means the differential input will be equal to V at positive minus V at negative. And they want it to be a 0. So all the time, V in at positive will be equal V in at the negative. Okay. Any question? Anything? every time. See that symbol? That's what we try to summarize for you. Inverting input to minus side, non-inverting input plus side, output to power supply. They get plus minus 8 volt up to plus minus 38 volt. Okay, in the left volt, you will be using 15 volts and a minus 15 volt. Ideal op-amp, open loop gain, AOL. Open loop gain, AOL, they want that to be infinity. Input impedance, GE, they want to be infinity ohm. And output impedance, they want to be 0 ohm. Okay, any question on that? This is more easy for you. You'll be working on the left one operation amplifier op-amp. Much better than bipolar amplifier. Now this is the one, okay, telling you what pin doing what for the operation amplifier 741. That's the name of the op-amp. Okay, practical op-amp, high voltage gain, AV, very high input impedance, very low output impedance, wide bandwidth. Okay. Output practical op-amp, output voltage Vout equal Vs positive minus Vs negative. That means the difference. Time AOL. A means the gain. O means open loop gain. Okay. That means the output Vout. You take the VD, okay, time VOL. VD, difference between two inputs. The gain, AOL, open loop gain of 741 op-amp, close to 200,000. When you buy the op-amp 741, for example, they telling you the gain. You cannot make it. That means the op-amp itself, they get the gain. That's what they call an open loop gain. Without any connection. For 741, what we using? The open loop gain is 200,000. The output of op-amp is never higher than power supply voltage. You see the gain, open loop 200,000. That's a very, very big gain. So, however, no matter what, the output of the op-amp never higher than power supply voltage. That means if you're using plus or minus 15 volts, and the output of the op-amp cannot be higher than plus 15 or less than minus 15 volts. So that's safety for your guy to working on. Even the open loop gain will be 200,000. When input apply is too high, that force the op amp into saturation. That means sometimes you see they get a gain 200,000. You try to apply 1 volt, output 200,000 volt. Cannot happen. So that's why they said when the input apply is too high, that will be forced the op amp into what we call a saturation. Okay? And the op amp output will be equal plus or minus saturation voltage. That voltage will be less than power supply, about 1.4 volt. That means if you're using a 15 volt or minus 15 volt power supply, so the maximum output of the op amp may be equal 15 minus 1.4. Okay, will be less than 15 volt. Open loop gain AOL is defined as the amplified output amplification without any external feedback signal connected to it, and for typical operational amplifier is about 100 decibel at DC, mean 0 hertz. That given in the specification of the op amp. When they build that op amp, they already given information for you. Now, on that one, an op amp had open loop gain 200,000 with power supply 15 volt and minus 15 volt. Okay, in this example, I given to you V saturation supposed to be less than 15, but we're using plus or minus 15 volt. That's just an example. In the real, they will be 15 minus 1.4 volt. Okay. However, in here we don't care. So that's why V saturation using plus minus 15 volt. Complete VD and Vout in the following table. Voltage, input plus 20 microvolt, input minus 40 microvolt. Okay, you see, I need to get the okay, let's see. Input 20 microvolt. And 40 microvolt. And the gain now try to understand on this thing. That will be V out. V out. Okay. If you calculate number one, VD. What is VD? Differential voltage equal
minus 20.
V in positive minus V in negative. That means you take 20 microvolt minus 40 microvolt. What you get?
Minus 20.
20. Okay. So basically in here, you can say minus, no, 20. Okay. VD means the difference. Okay. Minus 20 microvolt. Okay. First thing, we try to say what the limited for the output. If they at the saturation, okay, let's see, at the saturation, okay, I need one more. It's a 0 volt here for V out. Okay. That means you take the V out, divide to the gain. That's what you can get the V in differential. So the output, they can be saturated. Okay. Saturation at positive. Load 15 volt. Saturate. That will be given to you. V equal 15 volt. Divide to the gain 200,000. What voltage you get? Did 75?
Yeah, 75
Microvolt.
microvolt.
Correct. Okay. 75, right?
Yep.
Microvolt. We already telling you output of the op-amp cannot be higher than saturation. So at the saturation, this is the voltage right here. 75 microvolt. And V out at the negative saturation. That given to you VE minus 75 microvolt. That means right here. Okay, now when you're doing calculation, if V out higher than 75 microvolt, okay, then what V out equal? This is a plus saturation.
15 volts.
$15 volt. What they're telling you, any output higher than, okay, the limited, then the output have to be saturated or less than here. This is a plus V saturate. And now if it's less than minus 25, and V out equal minus 15 volt. That will be telling you, no matter what the gain or the input, if they higher than, okay, in this case 75 microvolt or less than minus 75 microvolt, output have to be saturated. they could be positive saturation 15, or they could be negative saturation. Any VL between the limit minus 75 plus 75 VL will be AOL time. Okay, input. Okay, now, in this case, what we have for number 1?
-4.
You get input differential is 20 times the gain. Four volt, right? Minus, is it correct?
Yes.
Okay. Now you try for me number 2. What we did,
70.
perfect 17. What we have,
14.
right? If anyone get a different, let me know. Okay, go to number 3.
-20.
Minus 20, right? Output will be the same, right? Minus 4, right?
Yes,
Yeah.
sir.
Apple.
Okay, number 4.
140.
What we have,
15.
15 volt saturate, right?
Yep.
Make sure you guys have to understand this cover in the final test. Next one, number 5.
-145.
Minus 1.45. 100. Okay, what we have?
-15.
Perfect. You guys understand. Not the problem. Next one,
65.
output
13 volts.
13. 13 volts.
number 7.
Isn't the last one 13 volts?
What do you mean the last one? What number?
Number
Number
6.
6.
Okay. I need to calculate it. 65 times 200,000. $13 volt. Okay, number 7.
Negative 100.
Minus 100. We out.
Negative 15.
Perfect. Last one.
Negative 40.
This minus 12. Or minus 8.
Minus 8.
Okay. Make sure that will be clear for everyone. You will be hit again. Okay. So up to this point, you get any question, anything?
Mr. Pham,
Yes, sir.
so it's almost like a band filter.
You're talking about filter?
No, the procedure is almost like a band filter. So anything that's above 15 or or below negative 15, it defaults to that.
No, that's just a basic for the differential amplifier. Filter, they can be blocking, or they allow the signal can go. That's what we're talking about. When the signal, they can go, for example, you get a power supply, 5 volt, 12 volt, DC. So basically, at the output of the regulator, we get the filter. Try to filter out, okay, the signal. Only DC, without any ripple. So when we go through that thing, then we can go into that. You can see how the capacitor, the filter, right? They
Ah,
will be working. Okay, so I just try to go through that. Okay, for the op amp, and we'll be stop it until next meeting. You can see the signal here. Input signal mode, single ended mode. What that means? You apply only one input, the other grounded, only one. That's single ended. Input applied to either positive or negative of the op amp, and the other input connected to the ground. That will be single ended. Differential mode. Okay, this is a differential mode. That means the signal applied to input 1 and input 2. The first one is single-ended mode. Second one single-ended mode. They apply to negative or they apply to positive. The other one will be routed. And differential mode, that means you apply both, okay, signal to input 1, input 2. Only you pay attention here. These two signals have to be opposite. This positive, this will be negative. Okay? Cannot be the same phase. And that op-amp can consider to be a noise. So they can reject it. Let's see what they say. Differential mode to opposite polarity of phase. Signals are applied to the inputs. That's a very important. Common mode to signal voltage of the same phase, same frequency, and the same amplitude applied to the input when equal input signal are applied to both input, they can show, resulting in a zero output voltage. So basically, the differential amplifier here, okay, only amplify your signal, okay? If you get a noise on both sides, op-amp will be trying to cancel that out. Only part your signal. Make sure signal applied must be opposite, okay? They cannot be the same phase, same amplitude, okay, or same frequency. That means the signal identical. That considered to be the noise. Okay? So basically, to the take one, the very, very important to you. That means the left volt. So that's why you get 3 days, Monday, Tuesday, Wednesday, to working on the left volt. Okay? Try maximum you can get. The thing is sometimes you already done requirement for the electronic. That means you can get semiconductor, bipolar transistor. Up to this point will be a differential amplifier, operation amplifier. Okay? And a little more, not much. You get it done, then you can take it easy. The thing is, everything you're doing on left phone, they record it into the server. We're looking into the server, we can know how many things you've done, what more you done, or what more you not done. Okay? You get a take one certificate. That's a very important to the program. You have to get that done. And you will be get the final test at the month of the almost and for the fall 2023. Okay, any question or anything? The reason is you only working on the lab. You don't have a lab phone at home. So that's why try to be in the class in order to get it done. Anything?
Professor? So with regarding the homework that's posted on the website,
Mhm.
are we gonna have any more homework past assignment 12? Because
Yeah.
assignment 12 is the last
No. Still get the homework on the one with the talking last week and this week. That means bipolar transistor. Okay. Differential amplifier. Okay.
The last homework assignment was bipolar transistors, yeah. Okay.
Yeah, but it's not much. Still more. The thing is, I take from when you're doing the lab board, you get the test at the end of each one. So that's why I using at least 70% of their question, okay, on the homework. So if you can get that done, easy for you to get it done when you do your lab board. The thing I want, if I given you that circuit board, I say, okay, now go ahead, run and do it. You can do it quickly. That means okay to me. Without any problem. Okay? So, we'll talk to you next Thursday. Good night, everyone.
Good
Good
night.
night. Thank you.
All right, thank you.
Okay, bye-bye.